In the previous tutorial, we modeled 4 devices and enclosed them inside of a top-view system implementation. We now see from the requirements that our system also contains software, a processor, and a memory. We need some component to receive inputs from some devices, such as motion sensor and magnetic alarm sensor, process the data, and send an output to other devices, camera and alarm unit. The good thing about AADL is that when you are not sure what kind of component you are dealing with, you can initially represent it as a system type. Then, when the design matures, you can change it to something else, for example, a device or a process. Since we know that this component will do some data processing and will probably use software for that, let's make it a process type. Add the process named controller and add its implementation, controller with threads. You can use any other names, just keep in mind that AADL is case insensitive. Don't forget to add the process as a subcomponent of our system, as we did with the devices. Now that we have our 4 devices in a process, we need to establish the communication between them. We'll do this with ports. AADL uses features for communication among components. Ports are communication interfaces used to exchange data or events. That's why there are event ports and data ports. We'll define ports for each device inside of their component type definitions. Use the keyword features, specify the port name and the type of the port you are using. In our case, because the motion sensor is sending a signal out when it detects movement, it will be an out event port. The magnetic alarm sensor does the same thing. It sends a signal when a window is opened. The controller process receives inputs and will need 2 in-event ports. It will process the data and determine whether the camera and the alarm unit need to be activated. It will send signals to both through 2 out-event ports. We can let our camera receive a signal to start or finish recording and send video data back to the controller. So let's add 1 in-event port and 1 out data port. The alarm unit will receive a signal from the controller, so it will need an in-event port. And finally, since the camera sends a video stream back to the controller process, we want to add a port on the controller process side to receive that input. Now that we've added the data and event ports, we can look at the graphical representation of our system again, where you can rearrange and adjust the position of components and ports. As you can see, one important detail is missing: connections. Even though we have devices and ports, there is no way to tell which out port is connected to which in port. Connections between the ports need to be defined in the top view system implementation as follows. Use the word connections, give the connection a name, colon, port, give the name of the component with the out port as it appears inside of this particular implementation, dot, give the name of the component's port, then place an arrow, give the name of the component with an in port as it appears inside of this particular implementation, dot, give the name of the component's port, semicolon. We have 5 port connections in total we need to specify. Feel free to pause the video to learn how to do it properly. If you see our systems diagram now, you'll see that all ports are connected. Now the devices can exchange data and events with the controller process. You may need to rearrange the ports in the diagram to see it better. In the next video, we will add processor and memory.